Can everyone hear me? That's working. Great. All right. Hi, everyone. I'm Paul Finn. I'm at the University of Melbourne. And this is all work that I did with Chris Duffy, and which I'm talking about today. So I want to start with acknowledging country. So yeah, we're on the Turrbal and Yagara lands. And I think I'm really grateful for Indigenous people's custodian of the lands and waters of Australia for over many years. And I really want to acknowledge that, you know, they've been educating and sharing knowledge for tens of thousands of years. And I think it's really nice that we get to kind of continue this tradition. And I really like that about conferences, as it's a way to kind of engage in kind of less formal, but also kind of the conversations and making knowledge together. So I really like that. So I want to pay my respects to elders past, present, and any Indigenous people who are here today or online, wherever you are. So I'll briefly tell you, so this is the two subjects that I'm talking about. So this is not important. I just kind of put this here as a thing. So there's two subjects I'm thinking about. One is called data analysis. This is an introductory statistics course for first year students. They come from all sorts of degrees. And then the second one is this second year, more theoretical statistics course for people who are doing a major in statistics. And I've got some student numbers to kind of give you a rough idea of like how many there've been over the however many years. I don't have the 2025 figures, but that's because I taught neither of these in 2025. So I was a bit lazy and didn't put the numbers in. So previously what we used to do is we had like, I guess what was a standard model at our school, which was we'd have 3 lectures a week, 1 tutorial and 1 computer lab. So each of these kind of standard sort of class thing. And yeah, I'll talk about so what we did is we changed this. The whole point was we wanted to try, we were experimenting with new things. We changed the model entirely. So we had 3 lectures, we had 3 lectures per week, so 3 hours. But then it doesn't look like a real big change, but we took that 1 hour tutorial and the 1 hour computer lab, and the whole point was to smush it together into a single 2 hour class. And I'll talk a bit about why we did this. So I probably don't need to tell people this, but you know, 2020 brought about a lot of changes in education, in Melbourne more so than anywhere else. So we went very rapidly into a lot of online teaching. People were not allowed to go more than 5 kilometers from their home. Like it was quite extreme, and we were in lockdown for a very long time. But we did come across, one of these things that we did is that by having all these classes all of a sudden move online, we came across some things that worked really well, that worked better online than they had worked in our classrooms. And the thing in particular that I noticed in statistics classes was that we had these, in the computer labs, like in our tutorials, students work together throughout the whole tutorial. And that's always been a thing. Students tend to work in groups, often on whiteboards, with whiteboards all around the room. And this is kind of that's the general model that we use for all our maths and stats classes. But then in the computer labs, they'd all be sitting at an individual computer, facing away from each other, and they'd sit there and work individually. And it didn't really matter how you kind of tried to do things. The students would probably work at their own pace, and they wouldn't do that. When we were doing things online, it turned out, well, actually, no, someone would share their screen. They'd be in little breakout rooms, one person would share their screen, and then they'd all be working together on the same screen, so they'd be working at the same pace. And that was the real reason why they didn't work together in a computer lab, is when you're sitting side by side, if you're reading, if one person wants to read everything, and the other person just wants to skim until they find a question, and then try and work out how to do it by like reading back the bits above, that's fine, but then they can't work together. And so this was one of the things that happened. So we noticed that this happened when they were working together, sharing a screen. We got this real benefit. And so the question was, could we bring this into our physical classrooms? And so what our solution, I'll tell you in a second why, so it was to have this pilot program where we wrote these electronic whiteboards, which are into 3 of our classrooms. So this is what they look like. They are giant screens. They're giant touch screens with a computer attached. This is what they are. So you can use handwriting, you can use Android and stuff like that. So that side of things is exactly like an ordinary whiteboard. You do not need the technology. But it was just easier to kind of have one screen where they could share. And I'll tell you now, like, actually, you don't need the technology to do this. It's something we worked out from the pilot is that actually, no, you don't need to spend the money on these giant screens. Just redesigning the tasks and making sure that there's at least one screen that's big enough that the students can work in a group is fine. So having a shared screen between 3 students and just have one computer was kind of equivalent to having this sort of system where you can get the students to work together. And that's something that I was like, so if you're worried, does this require lots of money, lots of technology? No. We found that the whiteboards largely, this does not like me. The whiteboards largely did not matter. The electronic whiteboards were not, the technology was not important. It is about this kind of restructuring of the activities and having just a screen that is big enough for people to see, and something that's a little bit bigger than this screen here, which people online can't see, but it's a standard, I don't know, A3 size screen, I guess. So something a little bit bigger than that is enough for 3 students to kind of sit there and work together. So part of the things thinking behind this design was like, again, more about active learning, feedback, engagement, inclusivity, authenticity. I mean, it's weird, but like most school students tend to kind of come across the impression that maths is something you do by yourself, and you sit there and you solve some problems. But statisticians almost never work by themselves. Like, that's the whole point. We have to work with discipline experts who've collected the data. We have to work with whoever we're trying to communicate the results with, so that we know, well, what is important to you, what sort of measures are important, what sort of questions you want to answer. So these sorts of things. So it is really about that collaboration, and that was kind of that thing that we really wanted to bring in, was that kind of, how do you become a statistician? How can you become a statistician and act like a statistician at school, at university, right? So rather than that thing. And also constructive alignments, we had a few things we put in. So first thing we thought about was like, how do we select and create the tasks? So we took existing materials. Rewriting a whole thing from scratch was kind of not something we had the time or the resources to do. But we did have some existing materials that we were prepared to rework. And then we kind of pulled out all the tasks where we thought, these are things where there's a useful collaboration here, or something like that. And it meant we could rip out a bunch of things that used to be in the tutorial question, where we'd say, oh, calculate the mean of these 5 values, or draw a scatter plot for these 7 values. And it's like, the only reason why we asked them that was because it was a tutorial. They didn't have a computer, or you couldn't guarantee they had a computer. And it became this whole thing, well, no, if they've got the computer already, they can just get the computer to produce a graph. We don't care if they can produce a neat scatter plot. That is not important, not by hand. So we want them to understand what it's doing. And so sometimes you do want to have some of those calculations once or twice, so it helps students understand what's going on, the underlying formula, but you don't need to do it regularly. And that was the thing. So we could take a lot of those things out. And so, yeah, we did a whole lot of stuff. So we did a whole lot of proofreading things. We made detailed teaching notes for the tutors and things. And one thing that I managed to get a little bit, just enough funding to do, was to not have to take my own tutorial. And I was like, so I didn't have any tutorials for that subject the first semester it ran, but I would go and drop in on a bunch of different classes throughout the week. And then I could see how different tutors and how different students were reacting to the different tasks. So things that worked really well in some groups actually didn't work well in others, and things like this. And so it was like, or sometimes it was the tutors, they would use things differently. And so being able to see that variety was really helpful in terms of redesigning things. So that was something that I thought was something that was relatively simple and like cheap, because it was like just my 2-hour class that someone else could cover was to do that. So here's like an example. Like, I mean, it's not like, so it was like, we gave them the graph, and it's like, produce the standard boring one, and then tell me 3 things that have been improved. Not everything that has changed is an improvement, and things like that. So practically, we had a lot of discussion about the various options. In the end, we settled on like OneNote for the introductory subject, because at the time we were still using Minitab. And then the other one, we used Markdown as a way to kind of do those. But then the key kind of things we were thinking of, we wanted something that would work on Windows and Mac OS. Microsoft changed things, and then the university updated things just before semester started. So it turns out that actually Windows and Mac OneNotes are not the same. And so we had to redo a whole bunch of stuff, and it just didn't work, which is unfortunate. But our students at our university have access to the Microsoft programs, so it was just kind of sticking within that the programs they're familiar with, that they have a license for. That was kind of the main reason for using those sorts of things. One thing that we did identify in the first semester we ran this was back in 2022, was that there were some students who didn't, like some students were just not using the software, right? It makes sense when you're working in a group that someone is going to spend the bulk of the time doing stuff. And most groups, they would rotate, but like from week to week. So most students only kind of did stuff some weeks. And so there was like some things which traditionally in a computer lab class you get practice doing, and then they wouldn't all have practice. So we kind of came across a way to fix that, was to put in some pre-lab tasks where the students would get to do work, individual work, where they'd work through things. We gave them really short, like the point was for them to take up to 15 minutes. So like kind of short list of tasks. We gave them hints, which kind of suggested how to do things. And then we gave them fully worked solutions, including like menus and screenshots and things like that to kind of help. So they had like a full list of answers for some things. And so that everyone could be confident that they knew how to do the things that they were supposed to be able to do in the software. So we were evaluating this. We wanted to kind of see whether or not the teaching redesign improves students' self-efficacy and their attitudes towards statistics. And then we also looked at which variables kind of related to final grade. So thinking about effectiveness, yeah, we kind of split it up into these kind of three things. So self-efficacy, engagement, and knowledge were kind of the three ways we kind of wanted to measure this. So students' attitudes. And then we didn't really measure engagement. We had a proxy. And then, yeah. So how do we do this? Well, up the top in the grey, this is the stuff that students responded to. This was surveys. And so they were voluntary. Students could fill these in. Everything down below is pre-existing data that we just got access to on an opt-out consent basis. And so the idea was, so we had student data, we had their attendance, we had their results, we had their marks for previous subjects, these sorts of things. We were a little bit worried about our sampling, but like because we had these general data we could compare, turns out like, so the statistics to the massed 110 subjects students, they tended to perform better overall in the subject than the ones who didn't complete surveys. I think that's not surprising because I think they were more engaged. I feel like in both of these cases, the kind of like the students that were more engaged were more likely to do the survey. But different measures, like interestingly enough, statistics, so that maths 200 to 0005 students, no difference in the grades, but there was a difference in their attendance. So they tended to attend about 4 more classes on average out of 11. So that's quite a lot. So this was kind of surprising. There was no significant changes in self-efficacy or attitudes towards statistics. I'll talk about this in a second. And then the only factors we found that influenced grade were attendance and prerequisite scores. So I can show you some graphs. So here's the attitudes towards statistics. So yellow is the initial, brown is the final, and it kind of looks all the same. There wasn't really much change. Some of them seem to go negative, which is kind of sad, but I mean, it's actually not the same students. So there's only like, there's a small, weirdly, out of the, I want to say it was 900 and something, maybe it's over 1,000, no, 900 and something, 900 to 1,000-ish students who could have filled in the surveys. We had 36 who filled them in. So survey response rates, terrible. I'll talk about that later, but yeah, and only 5 did both surveys. So they're not the same students in these groups either. So grades based on attendance. Attendance data was pretty good. So there's an NA because some tutors didn't fill in their attendance data necessarily. So if it was missing, then we gave it an NA, but we know which ones actually did attend and which ones didn't. Yeah, so the zeros didn't attend any classes. The NAs, there are no records. And you can see there's kind of an increase in final grades. This is the second year subject, the theoretical one, where you can see compared to their prerequisite score. And so most students actually tended to do pretty well, but the ones who had a weaker background tended to struggle more. So there was much more. Can you see my cursor? Yes. So this group here. So yeah, students who didn't do so well in the prerequisite score, the ones who had a close to a pass, so somewhere between 50 and 60, tended to make up more of the fails in the overall. And here's the results for the first year subject. The x-axis scale probably doesn't make sense to anyone who's not Victorian, but that's not from Victoria. But the idea is like a 30 is an average score in VCE methods. but it's not really a pass-fail sort of system. So, but yeah, you can generally see that like students who started off with the stronger backgrounds definitely tended to do better, but like a huge number of students actually did well, and like you can see the majority of students passed. One thing that turned up in the surveys is how much outside work students were doing. We didn't think about this, but we should have also asked about caring responsibilities. We only asked about how much time do you spend on work or it's in the notes that I can't see. I can't remember. It was yeah, it was based on how much work, and it was just work and something else. Oh, I think it was just paid and unpaid work. That's what it was. But we should have asked about caring responsibilities. That's something we should have done. Interesting enough, like gender, like there was no difference. More or less no difference. One thing that I did think was like it's not statistically significant or anything, but I did notice like, so it's not unusual to see a spike of students at 50 where people who get close get bumped up. What surprised me was that it happened in the males more than the females. So this could be potentially be a system of like unconscious bias. It could also just be the fact that there's like, this is percentages, so it could be a percentage based on like the number of students, but I'm not sure. So that was like slightly concerning to me. And we'd actually asked more categories of gender. We just had to like combine them because of small response groups to kind of the small response numbers to kind of preserve anonymity. So in general, it's really well received by teaching staff. They kind of found that the students did engage more in the classes. They did tend to work together in the labs. It did bring about the good things that happened from working online into the in-person classroom. And yeah, once we put it in the pre-lab tasks, most students actually were much more confident with the software. We got better answers on their assignments, these sorts of things. I would say the poor response rate was disappointing. Yeah, we did a bunch of things. We had personalized emails and personalized contacts and reminder emails. I did think that students might care about statistics since they're taking a statistics course. This is me being naive, and also like I was not a typical student. I was absolutely this person. Like when I was a student, I was doing a stats subject. I'm definitely going to participate in a study about it. But I am not a typical student. I understand that. I was just hoping they might be slightly closer to me. Anyway, yeah, and in general, we found that attendance actually showed a really strong relationship to grade, and it was stronger in our first year subject. And it's like, I think perhaps with that transition to university, the students who could attended classes more, they tended to form more study groups, get more peer learning and things like that. So I think that was a big part of it, and it helped with their transition to university. So I think that is potentially the reason why they're. I was going to say, we did also get some written survey questions, and so students had like lots of really great comments. We asked them about what they think statistics is, both before and after, and it didn't really shift. But I mean, it was different students who kind of replied, but students gave like quite. It was kind of interesting, like the range of responses that students gave. So I think versus from. So some students were talking more about like statistics and how it could be used like as a useful thing, but then a lot of them were actually talking about, no, this is actually, I can see how this is insightful or relevant, or like it's interesting because I find there was something that they just found interesting. They just really liked working with data. They liked visualizing things. They liked communicating it and these sorts of things. So there's kind of like a huge range of responses, but nothing that was, we just didn't have enough responses to really have say anything about it. But thank you. So do we have time for questions? 4 minutes? Yeah. I can't keep track of the time schedule. My computer is still on Melbourne time. Yeah.
Yeah, excellent. So you mentioned that you had pre-lab tasks.
Yeah.
I was wondering, did they actually do it?
So did the students actually do the pre-lab tasks? So the answer was yes, but that's because it was like assessed basically. Like indirectly, like if they wanted to do like whether they did them before the lab, that was not everyone absolutely did all the pre-lab tasks. But it was, I think it's fascinating in my class. I definitely had students who would say, like when someone was trying to do something and they're like, don't you know how to do it? It was in the pre-lab. And so I like that the students were kind of pressuring each other to do the pre-lab and like letting them know that, hey, well, no, it's really easy. It was in the pre-lab. And so I think that was kind of a nice little subtle peer pressure. but it was also more that like most of them did them in the end. They just did them. A bunch of them did them when the assessment came up rather than before the class. But as long as one person in each class had done it, they were fine.
So when you talk about attending people that didn't attend any classes, so you're talking about just a point of clarification. Is any of the class attendance compulsory?
So no, none of the class attendance is compulsory.
And what about stuff?
Okay, so none of the class attendance was compulsory. So online things are the only things you can do online at the time. Like this is 2022. This is after we'd gone back to full-time in-person teaching. The only thing you could do online was the assessment.
So you're not.
Oh, there's recorded lectures. Yeah, they could watch the lectures and then the assessment, but the tutorial, like I mean, the stuff was there. They could download it and work through it on their own if they wanted to. But it was, yeah, and yeah, there was also the thing with they could. I was going somewhere with this. But we checked the assessment of how many students have submitted assessment, and like there was no difference between the students who filled in the survey and those who didn't. But I mean, obviously, like completing assessment actually did affect their grades, but that's unsurprising because it directly affects their grade anyway. Yeah. I think I better. All right. Thank you.